Hey Math 30-2 students, we're looking at lesson 6.3, solving exponential equations. So what they're telling us is a chessboard has 64 squares which alternate between two different colors. According to this pattern, 1 grain of rice was placed on the first square, 2 grains of rice are given on the second square, 4 grains on the third square, and so on until all 64 squares are covered. The pattern can be modeled by this function. So your A is always your y-intercept value, meaning your starting amount. And in this case, we're starting with 1 grain of rice on the first square. So that's going to be our value. Now, what you'll notice is to get from the first square to the second square, you're going to double and then double again. So our B value is doubling, which means that it's number 2. And then we're going to have x minus 1, where x represents the spot that we're in, so the square that we're on. And y represents how many number of rice grains that we have, number of rice grains. So that's what the x and the y represent. So the first question, they want to figure out how many grains of rice correspond to square 44. So you're going to go y equals 1 times 2 to the power of 44 minus 1. And then we know that 1 multiplied by anything doesn't change anything, so we don't have to write the 1. So we're just going to write 2 to the power of 44 minus 1 is 43. So in your calculator, you're going to put 2 to the power of 43. And then that's quite a large number. You're going to get scientific notation. This means that it's 8.796 times 10 to the power of 12. That means you would have to move that decimal spot 12 spots to the right just for us to figure out how many grains of rice we'd get. Now we want to figure out what square on the checkboard would correspond to 128 grains of rice. So we're going to go 128 for y. 1 times 2 to the power of x minus 1. So I'm going to show you how to do this in your calculator. You're going to put this as y1 in your calculator and this guy as y2 in your calculator. And then you're going to graph them logically. And then we're going to figure out what the intersection between these two sides are. So in my graphic calculator, you're going to go 128 for your y1 and 1 times 2 to the power of, if you have an older version calculator, you're going to have to put brackets around x minus 1. Now for our window, we know that our x's represent how many spots on the chessboard we're talking about. So we know that there is, 60, let me go back to the question. We know that there are 64 squares, so we're going to go, our x should go from 0 to 64 squares. And we know we're trying to find out when we have 128 grains of rice, which is what our y stands for. So we just have to pick two numbers around 128. Okay, so I'm going to pick 0 to 200. Now I'm going to graph it, and what I'm trying to find is the intersection between these two equations. So I'm going to press second trace number 5. You're going to get as close as possible with your calculator to that intersection, and you're going to press enter 3 times. Enter, enter, enter. And the intersection should be 8. So x equals 8. That would be my answer. So that would be on the 8th spot on the chessboard when I have 128 grains of rice. So in example number 1, I'm going to show you how to do common base method. So this is another method for solving. So we're trying to do this without graphing. Okay, so what I'm going to do is I'm going to change each of these to 2 to the power of something. So 2 to the power of 1 represents 2. And then 4, we need to write it as 2 to the power of 2, because that's 2 to the power of 2 is 4. So we're trying to replace them with all the same base number. Now that 2x doesn't go away, so we still need to write that. And then 1 we can leave as it is. 1's the only number that I really ignore. Otherwise, I always write them as 2 to the power in these cases. So at the bottom, 2 to the power of, if I put in my calculator, 5, I believe, replaces 32. So now what I'm going to do is, the rules are that whenever we have a power raised to a new power, we multiply these guys together. So 2 times 2x is 4x. And then what I'm going to do is flip these guys. And what happens is whenever you flip a base, the power becomes negative. So I'm going to have now -5, but it's now at the top of the fraction. So you'll always want everything at the top level. And then to join these guys, you're actually going to have to add them, because two bases, when they are the same, you add the powers. So 2 to the power of 1 plus 4x equals 2 to the power of -5. Now the reason we use this common base is because when we have the exact same base on either side and there's only one of them, we can actually cancel them off. They disappear, leaving us with 1 plus 4x equals -5. So we're going to subtract 1 on both sides to give us 4x equals -6, and then we're going to divide both sides by 4. So x equals -3/2 if you simplify. So you can always check this answer by doing graphing or substitute it back in to see if left side equals right side. Our next one, what's in common between 125 and 5 would be the base of 5. So we need all of it to have a base of 5. So the square root of 5 to the power of 3 will give me 125. Now the next thing I want to do is I want to change this square root to a power. This is a power. The number, if you don't see it as a 2, this is called your index. And when we write it as 5 to the power of, it should always be power at the top and index at the bottom. It still means the same thing, but in fraction form. So 5 to the power of 3/2 still means the square root of 5 to the power of 3. It still means the same thing. The reason we do that is now the power or the bases cross each other off, leaving us with x plus 2 equals 3 divided by 2 is 1.5. Then I'm going to subtract 2 on both sides. So 1.5 take away 2 gives me -0.5 as my answer. And then we want, for the last one, the base to be 3. 3 to the power of 2 is 9. And 3 is already as a base of 3, so we leave it as it is. Then I want to distribute this 2 to the brackets to the values after it. So it's going to be 3 to the power of 2x minus 2 equals 3 to the power of x minus 3. Now the bases cross each other off, leaving you with 2x minus 2 equals x minus 3. You want to bring the x over here, and you want to bring the -2 over here. So they're going to swap places. So 2x minus x, because you're bringing it over, so the sign switches. And then you're going to have plus 2, because you're bringing the -2 over. So -2 becomes plus 2. And then -3 from the right stays as it is. So 2x minus x is just x, and then 2 minus 3 is -1. So that's your answer. Now the next example, example number 2, you can't get the same bases. 3, 2, and 5 do not have bases in common, so you're actually going to have to use your calculator and put this as y1, this is y2, and then you want to graph and find the intersection between the two sides. So that's the other technique. So 3 to the power of 3 to the power of x minus 5. Make sure you put that power in brackets. And the right side, we have 2 times 5 to the power of x over 4. So we want to graph that, and as we can see, we're trying to find the intersection. So we're going to go second trace, number 5. You're going to move your cursor until you get as close as possible to the intersection. And then you're just going to press enter 3 times. So once you press enter 3 times, that will give you the intersection. So the intersection should be about 8.885. So they want you to round the answer to 1 decimal place, so you'll say x equals 8.9. So what method did we use? We actually had to do the graphical method because we couldn't solve this using the common base method, right? So for this, I used the window. The window that you could use to find this would be 0, 50 to 1, and then your y value could be 0, 100, up to 1. So that would be a window that you could use to see all these answers here. For our next examples, we have 2 equations. We can use the half-life equation or the doubling time. So if you see that something's increasing by double the amount, so it's going from 2 to 4 to 8 to 16, that would be doubling exponential function. So you would use this equation. When you see something is going down and they give you a half-life, like you're going from 100 to 50, and they want to know how long, you would use the half-life equation. So in this case, they're giving us the equation to use for underwater diving. So it says that we have 100% visibility at the surface, but only 25 visibility 10 meters below the surface. We want to figure out the half-life. So they're telling us what all the variables are equal to. So we know that we're going to see 25 eventually, but we started off as 100. So A0 is always your initial starting point. And you're going to have 1/2 to the power of, we see at 25% we're at 10 meters, and then we need to solve for h. Okay, so in this case, we could do common base method. We could divide by 100 on both sides. We can get 0.25. And on the right side, it would be 1/2, which is 0.5 to the power of 10 over h. Now, 0.5 to the power of 2 replaces 0.25. They mean the same thing. But now I have the same basis, so they cross each other off, leaving us with 2 equals 10 over h. And then I can switch these spots and get h equals 10 over 2, so h equals 5 meters. So that means that when we go from 100 visibility to 50% visibility, it's going to take, it's when you go 5 meters below the surface of the water. Example B, if you were diving at a depth of 15 meters to the nearest tenth, what's the visibility? So we're actually going to solve for A of x, which is one item. We still have 100 visibility at the surface. 1/2 to the power of, we're 15 meters below the water, and our half-life is still 5. So we can't, once we have that half-life, use that in all the parts of the question. So 15 divided by 5 is 3. And then we're going to put that into our calculator, and we'll get that we're at 12.5% visibility. Example number 4, again, they're giving us the equation. We just have to figure out at what temperature was the cheese kept in the fridge if it lasts 85% of the time of a usual particular type of cheese to the nearest 100. So we want to figure out the temperature that it's being kept at. So first we're going to take 130 and we're going to multiply it by 0.85, and that gives us 110.5. So we know that that is the, if 130 represented the initial number of hours the cheese was put in the refrigerator, then we want to find out 85% of that. So we want to figure out the temperature, which is capital T. So we're going to put 110.5 equals 130, 1/2 to the power of T over 43.3. Now we're going to put this into our calculator. This will go as Y1, this will go as Y2. The window that I would use would have been 0, 150, and 1, and Y. For Y, I went from minimum 0, max 150, and scale as 1. Then I'm going to press the button second, trace, number 5, and I'm going to press enter 3 times. And that's going to give us a temperature of 10.15 degrees Celsius. So this is to the nearest 100th. In our last example, it says, if you want to keep the cheese for 5 days, we're going to solve for what temperature should the refrigerator be set. Round your answer to the nearest 10th of a degree. Okay, so 5 days. Remember, our whole situation is an hour, so we're actually going to need to figure out the hour. So that's important. So 5 days, you're going to have to multiply it by 24 hours in 1 day, and that gives you 120 hours total. So we know that we're going to get to 120 if we initially start at 130. 1/2 to the power of T over 43.3. So it's the same kind of work as the previous question, except that we just had to figure out how many hours are in 5 days. So again, we're going to go Y1, Y2. We're going to use the window 0 to 20 going up by 1, and Y 0 to 150. So our min is 0. Our max is 150 for Y, and our scale is 1. And again, we're pressing the button second, trace, number 5, enter 3 times. And we should get that the temperature is 5.0 degrees Celsius, and that's to the nearest 10th. So that's our final answer. So that is your lesson 6.3. Hope you guys have a good day.